Good day, this is Jim Bytel from Columbia Gorge Community College Renewable Energy Technology Program. This is RIT 120 Hydraulics. Today we're going to have a discussion of the pressure reducing valve, which is the next valve in line in our discussion of pressure control valves. Okay, what is the purpose of a pressure reducing valve? As the name implies, it's to limit and maintain outlet pressure even if there's a higher pressure at this inlet. Okay, look at the schematic and just tell me what the pressure reducing valve, how it differs from a pressure relief valve. So first off, pressure relief valves are normally closed. Look at this guy. It's normally open. Okay? So it's normally open. Pressure relief valves sense pressure from the inlet. This guy's sensing from the outlet. There's a check valve bypass. And finally, there's an external drain. Okay, so it's everything the pressure relief valve isn't. It's its exact opposite almost. Okay, so knowing these characteristics that we've just discussed right here, how do you think a pressure reducing valve works? Well, if it's sensing pressure at the outlet and it's normally open, and if pressure exceeds a certain value set on our biasing spring at the outlet, it sounds like it would close. What it's doing is basically continually monitoring our outlet pressure, and if the pressure gets too high, it starts closing itself down, thereby limiting and maintaining our outlet pressure even if the higher pressure at the inlet. Okay? Why is it externally drained? Well, because R is still a pressurized port. Okay? Because even though you're reducing, let's say, from 1,000 psi and your pressure reducing valve is set to limit pressure to 500 psi, R still has 500 psi on it, and you cannot internally drain that, okay? So you need to externally drain a pressure reducing valve. Okay, why is it checked valve bypass? Well, to permit operation of this thing in reverse. Just like you can get in your car, put it in reverse and drive all the way to Portland, it is not a recommended practice to do so. So that's why we put our little check valve bypass in it, because cylinders are double acting and your cap and rod end can act as both inlets and outlets. And so to retract or extend these things, as the case may be, you need to permit reverse operation of this thing without interfering with it. Okay? So one thing I did not say here, where is it installed? The general rule for a pressure reducing valve, close as possible to the branch of the circuit you want the pressure reduced at. Okay, let's say you're trying to reduce the pressure given to an actuator. You want that pressure reducing valve as close as possible to that actuator to accurately reduce the pressure, because there's a certain amount of pressure loss within lines, etc., etc. So you want to minimize that. So put the pressure reducing valve as close as possible to the actuator. And again, it's close as possible to the actuator. It's in the circuit. It's in the hydraulic circuit in question. Okay, so let's just do a quick look at our little cutaway here. Put on our X-ray glasses and look at this guy. Let's just do the this lower passage first. Here's our pressurized flow, and here's our check valve. It tries to go this way. It can't, so it is forced to go via the check valve. It's forced to go through here. It's this unique bottle-shaped plunger that allows, spool, that goes, that allows the passage. It's normally open. It normally passes P2R, okay? And it's monitoring pressure at its outlet on the bottom of this spool. When pressure exceeds a certain value on R, let's say, again, 500 psi, it starts forcing this spool up here, basically closing off this passage from P to R, allowing that pressure differential to develop and basically reducing the pressure at to R to the desired 500 psi, whatever it might be, but still allowing flow. So you've reduced pressure there, okay? And again, it's externally drained because if fluid leaks back here, you need to find some way to get it back to the tank. That should be a dot, dot, dot line there. Because again, R is a pressurized port and you wouldn't want any back pressure to develop, because if this is an enclosed space here, the spool would never move. Okay, you got to drain that. And where are drain lines terminated? They're terminated above the reservoir level. Okay, now we want to run it in reverse. If we want to run it in reverse, all this gobbledygook is in the way, but that's not a problem because this fluid goes here, pushes the ball off its seat, and continues on its merry way. So that's the basics of a pressure reducing valve. It's normally open and it will close itself down when pressure at the outlet gets too high. Typically it's checked bypass, it's externally drained because R is still a pressurized port. And where is it installed? It's installed as close as possible. Okay, so let's go ahead and just put it in a circuit. So here is a circuit, hydraulic circuit. Cylinder A, we want as much force as possible to. Cylinder B, let's say it's, I don't know, like it's grabbing something that you don't want to crush. You know, cylinder A is gonna, that's our crusher. Cylinder A is our crusher. Cylinder B is just our grabber. We're gonna grab the side of like some fragile tube and not crush it. We just want to hold on to it. But cylinder A, we're gonna go ahead full power. Okay, so we've set this, our pressure relief valve, which by the way is right here, to 1,000 psi. And let's say we set this guy to 500 psi. Okay, because that's what we're not going to crush. That's not when that is the value at which we will grab onto that thing and not crush it. Okay, we go ahead and slide ourselves to a straight through position. Pressurized flow enters cylinder A, and because the pressure reducing valve is normally open, so does the cap end of cylinder B. It's permitting flow. And now cylinder A and B extend. Until pressure starts rising and rising, and it senses right there until it reaches 500 psi, at which point the pressure reducing valve will close. Cylinder B has achieved its pressure requirement of 500 psi. It's a reduced pressure from 1,000 to 500, but cylinder A, pressure continues to rise and rise and rise until our main pressure relief valve at 1,000 psi opens up, and cylinder A can go ahead and do whatever at the maximum sister pressure of 1,000 psi, whereas cylinder B is limited to 500 psi. Pretty neat, huh? Okay, now we want to go ahead and retract all these guys. Excuse me. And what we do is shift ourselves through a cross connect position. Pressurized flow enters the rod end of cylinder A and B. They both start to retract because as fluid moves out of the cap end of B, it simply pushes aside the check valve and goes through, permitting reverse operation through the pressure reducing valve. Sometimes you'll see them actually internally hooked up inside the pressure reducing valve. It's all one thing. Sometimes you may actually have to install a check valve in the correct orientation, mind you, to permit reverse operation of the pressure reducing valve. Relatively simple. Be aware that there are, as simple as this seems here, there are two kind of flavors of pressure reducing valves. There's a constant pressure reducing valve and a constant reduction pressure reducing valve. So a constant pressure is the one we kind of just talked about. Basically, it maintains, I'm going to write that down. It maintains or limits to set value. Like for this example, 500 psi. It's maintaining it up to 500 psi. Whereas there's also a different flavor, which I've not really discussed in detail, but just be aware that there is something out there called a constant reduction pressure reducing valve. Basically reduces your input by whatever set amount. By set amount. Okay, so let's say we've got a constant reduction pressure reducing valve that reduces by 200 psi. Let's say, for example, 200 psi. And you've got 1,000 psi input. Well, the outlet would be 800 psi. Same valve with an inlet of 1,200 psi, you would have an outlet of 1,000 psi. Okay. Whereas this guy, if we set it at 500, regardless of the input, we should ideally see 500 psi at its output. Okay, so just two different flavors of our pressure reducing valve. That is pretty much it for the pressure reducing valve. But again, just remember these key characteristics that we've discussed. It's normally open and it closes when it's energized. It senses the outlet pressure. It's constantly maintaining that outlet pressure. Typically, it's installed with a check valve bypass. It's externally drained, typically located as close as possible to the point of work, and its whole purpose in life is to limit and maintain outlet pressure, even if there's a higher pressure at the inlet.